Hey y'all, welcome back to Mr. P Math Teacher. Make sure you smash that like button, turn on that little bell, and subscribe.
All right, so today we're going to do section 3334. The good news, which I never even told you, because then I think I just started talking about bad news. But the good news is we're going to take a break from proofs for a minute. No. Sorry, Oliver. I know. You guys were getting good, really good at it, gaining some serious momentum. But I thought we'd take a break and then take a step back and do some things that you guys did last year in Algebra 1.
Go back on Monday.
To proofs?
Yeah.
Not yet. No. Tuesday. But no, not quite. We're gonna do this for a couple of days. So section 3334 is like something that you guys absolutely hammered in Algebra 1. How you doing, bud?
Good, how are you?
I'm good. So I think you'll find this pretty easy and accessible as well too. Are any of you in Algebra 2 right now? A couple of us.
How the heck can you be in both?
You guys are doubling up for what purpose?
Just to get it done, so that you don't have more stuff to do later.
Okay, freedom to do stuff later. Okay, got it. I had a kid in my last period class that was doubled up in Algebra 2, and I didn't realize that was, I think 2 of them were. And I didn't realize that was the case. So that is like important for me to know. So now I know that. So that's cool. All right. Anyway, so those of you that are in Algebra 2, this will be very accessible. But honestly, you guys learned all this in Algebra 1. So here's what we're going to focus on, okay? Equations of lines and slope is the big thing that we're going to do. 3334 on Google Classroom. So equations of lines are the main thing that we're going to focus on, and also slope as well too. Okay, so just in general, I'm just going to put my iPad down. Tell me, like when I say an equation of line, what type of things pop into your head?
Y equals mx plus b.
Yes. For the most part, you guys really enjoy the formula y equals mx plus b, but let's pick that apart. X and y usually represent like where we would plug in like a number if we're actually like trying to graph it. However, what does m represent? Slope, and that's huge, right? I mean, you guys spent a long time talking about slope, okay? So we're going to talk about computing slope and what that means and the types of slopes we can have and such. What about b? What does b represent?
Y-intercept.
Y-intercept, very good, right? So that was where on your y-axis where it crosses that axis, okay? All right, so y equals mx plus b is the form that you guys are most comfortable with. However, I'm going to show you other forms that are more useful, and we'll use those as well too. But a lot of the answers when we're writing an equation of a line will end up in y equals mx plus b form. So let's do a little quick recap on slope though. So slope is represented by the letter m typically. However, what else do we use to tell us slope or remind us what slope means? Like when we think of slope, what's another way that we can think of it? Slope is equal to rise over run. So it's like when you guys first learned slope, we talked about it like rise over run. Rise represents your change in what coordinate? Y. Because rise up and down would be y. And then divided by your change in your... Has anybody seen that symbol before? Triangle? Does anybody know what that means?
Oh, I've seen it.
Okay.
Oh.
It might be in science class you might have seen it.
Measure of?
Not measure of. Change is what it represents. You may have seen that in science class as well as math. But triangle is represented by change. So change in y divided by your change in x. Okay. Now, another way that you can memorize this, that y's go on top, is you could spell rise with the letter y. So R-Y-S-E to remind you that y goes up top. Okay. All right. Now, so usually when we find slope, we find the slope between two coordinate points. So we have our coordinate points here, x1, y1, x2, y2. So my change in my y value is my rise. So it's this distance right here. Does anybody know how I would find that distance? What I would do to those two numbers? Y2 and y1? Subtract them. And if I were to find my run, my distance between x1 and x2, I would subtract those x values. So when I do rise over run, I need to subtract my y values. So that's how I end up with y2 minus y1 over x2 minus x1. Have you seen that formula before? Of course you have. That's where that comes from though. It's your vertical change, it's your change in y values divided by your change in your x values. Okay? All right. The slope of any vertical line. Let's go off to the side over here and make a little graph. Actually, let's make this black. All right. And then let's say we have a vertical line. Like this, okay? All right, so this is our vertical line, f of x, whatever. Tell me about the slope of that line.
There isn't one.
There isn't one. Because if you think about rise and run, does my blue line rise, run, or both?
Both. Right?
Rises.
It could run.
When we think of run, we think of left and right. Is it going left and right at all?
So it's right.
It only rises. Yes. So it only rises. You guys did good. I was just letting you think about it for a minute. Just stare at you instead of like immediately giving you the answer. But our slope just rises. It does not run. Which means if we think about slope as a fraction, rise over run, my run would be 0. Can you guys divide by 0? No. What happens in math when we try to divide by 0? What do we call that value? We say it's undefined, which means the slope of my vertical line is undefined. All right, that's a very key point. So if we have a vertical line, my slope is undefined because it rises, but it does not run, and I cannot divide by a run of 0, okay? When I write the equation of a vertical line, it looks like this. X equals A. Oliver told us the equation of a line is y equals mx plus b. If we have a vertical line, it is just x equals A, okay, which would represent an x value, and we'll look at an example of that in a minute, okay? Let's say instead I have a horizontal line, though, so something that looks like that. So let's say that's g of x. Talk to me about slope of that horizontal line. Does it rise? Does it run? Does it do both? Does it do neither? What do you think? Runs, doesn't rise. So if I do rise over run, but my rise is 0, I would do 0 divided by a number. What is 0 divided by a number?
0.
Yeah, it exists and it equals 0. Okay, so then the slope of any horizontal line is 0. And the equation of a horizontal line, instead of x equaling some number, the equation of a horizontal line would be y equals some number. So I'm just going to call it b. Put a b right there on my graph that I made over there, and I'll put an x, or I'll put an a right there. That doesn't look like an a. Looks like a 9. Okay, tell me about parallel lines.
They have the same.
Same slope and same y-intercept.
Same slope, but different. Yeah, because if it had the same y-intercept, it would be the same exact line. Parallel lines have the same slope, but a different intercept. Okay, but I'm just going to say slope, so same slope. So parallel lines, they do not intersect, right? They don't cross. Slope is your rate of change. If your rate of change is the same, if two lines are growing at the same rate, they will not cross, okay? All right. Perpendicular lines. Tell me about the slopes of perpendicular lines. Well, first of all, what are lines that are perpendicular? They cross to form what? 90-degree angles. So right angles, 90-degree angles. Okay? All right. So if that's the case, their slopes can't be the same, right? Because they're going to intersect each other. So they're going to have different slopes. Does anybody remember how the slopes of perpendicular lines relate to each other, Haley Klein?
Opposite reciprocals.
Very good. Opposite reciprocals. Let's talk about what that means. Reciprocal refers to what?
Opposite? Like flipped?
Flipped. And what is flipping? It's a weird way for me to ask this question, but a fraction, right? Numerator and denominator. So reciprocal refers to the fact that like slope is represented by a fraction. If you take the reciprocal, you flip the top and the bottom. Opposite refers to what? The sign, so positive or negative, okay? So if I have a slope that is 5/3, what would be my opposite reciprocal of 5/3? Close, -3/5, right? So negative 3 over 5. So reciprocal is 3/5 for sure. Got to put that opposite piece in there, change the sign. All right. Can't get nothing past you guys. Let's say my slope was negative 6.
Positive 1/6. Wait.
Molly said positive 1/6 and then immediately reflected on her answer.
Like, because it has to be a fraction, right?
So you would think about negative 6 as like negative 6 over 1, right? So then you flip it, becomes a 6th, and I need to change the sign as well too. So it goes from negative to be positive, okay? All right, we okay there? All right. Let's do some examples of finding slope. All right, example 1, find the slope of the line that passes through the pair of points, negative 3, negative 4, and 5, negative 1. All right. We know that our slope formula is y2 minus y1 over x2 minus x1. So let me tell you a little thing that can make your life a lot easier. I need to plug numbers into that formula to compute what my slope is. I would start by labeling my points. So I would say this is x1, y1, x2, y2. So don't forget that each coordinate point has an x value first and a y value second. Okay? So I'm going to label my points, and then I'm just going to take those values and plug it right into my slope formula. So y2 we labeled as negative 1, minus y1 we labeled as negative 4, over x2 minus x1, which would be 5 minus negative 3. All right, negative 1 minus negative 4,
3.
positive 3. 5 minus negative 3,
8.
good. So my slope is 3 over 8. So if I were to plot this slope, like on a graph, I would start by whatever point I would start at, whether it's a y-intercept or a point that was given or something like that. What directions would I go?
Up 3, right 8.
Up 3, right 8. Okay? If there was a negative in there, then that would change one of those directions, but not both. For example, if my slope was negative 3/8, instead of going up 3, I would rather go down 3. I always like to, when I plot my points, I always like to go from left to right because I like to do math the same way that we read the English language. So I always go from left to right. So if I have a negative slope, usually what I do instead of going up is I go down, and then I just always go right. However, that would be equivalent to saying instead of going down 3, right 8, if it was negative, I would go up 3, left 8, if there was a negative as well too. Those are equivalent things. And we'll practice that and look at that here in a minute. Okay? All right, this one says find the slope of line D, but you know what? Let's find them all. We're going to find the slope of A, slope of B, slope of C, and slope of D. All right. Now, if you have a graph, that's like such a gift. Oh my gosh, speaking of gift. I need to take attendance. I don't know why I said that. Oh, speaking of gift, it's my dad's birthday today.
Tell your dad it's a happy birthday.
Happy birthday, Terry. He's in Ireland right now. Did I tell you guys that already?
Ireland?
Mm-hmm.
Ireland for what? Golf?
He does not golf. He just went, okay, well, I'll expose my parents here. My mom is a Steelers fan.
Oh yeah, the game is.
Yeah, and they,
Don't the Browns play? Early
we play in London
Yeah, but don't they
this
play
weekend.
Like 9:30?
Why are they playing
It's
in
like-
these places?
Yeah, wait, what's that happening?
to try to promote NFL globally, I guess.
9:30.
They've done it for a couple years now, but
Yeah, it's a little dumb.
yeah. Anyway, so I think there should be flying back, so they're probably boarded on their plane by now, maybe. I don't
Wait,
know,
how? Didn't
but
you say
Wait, so they
something?
went all the way over there just to watch American football, but so they're not in America?
correct. The game was last weekend.
It hasn't even happened yet.
What's that?
Oh, it was on Thursday.
It was this past weekend. It was Sunday last weekend.
Oh yeah, but they just stayed.
They stayed, yeah, because they wanted to. My mom's never been international like that
No, 'cause
before.
my friend's
My dad has, but
Dad was also in Ireland. They played the Vikings, right?
honestly, I don't know, man. I have no idea. Okay. All right. Attendance is taken. Anyway, happy birthday, Terrence.
Terrence.
Terrence is his
I
name.
was carrying.
Huh?
Just carrying it, man.
Yeah. Yeah. I just call him Pop. Usually what I do when it's somebody's birthday that's like close to me, I'll call them and then I'll let you guys sing them happy birthday. But like, Dad's on a plane right now, so I'm just,
Dang it.
yeah.
Video.
Oh yeah, I could show him this. Well, we'll do it at the end. Okay, so we want to find the slope of each one of these. Oh, you mean like me take like a video with you guys and then send it to the old man? Yeah, I can do that. All right. How old is he today? 62.
7.
62. 5 more years. Do you think that'll still be a thing in 5 years?
Yes.
Oh, for sure. And then you're gonna, since I'm not gonna be here, you're gonna need to like, I don't know.
I'll reach out to
Tell
you.
me?
I'll email you.
Wait, what day is it? It's the 4th, right?
The 3rd. Yep, October 3rd.
October 3rd.
Yep.
5 years. So
Yep. All right.
2030, October 3rd will be 67.
That's right. That's a big birthday. Okay, find the slope of line A first. We're gonna do A. Okay, so if you're given a graph, that's quite a gift because instead of doing my slope formula, I can just count from the graph and make it super easy. Okay, so I find line A, which is right here. I don't want to do it in red. I find line A, which is right there. But what I need to do is I just need to count to get from one point on that line to another point on that line. Okay. So, am I going to have a positive slope or a negative slope? Positive, because I'm rising from left to right. Okay. How far am I going up? 4. And how far do I go to the right? Good. So my slope is going to be very easy. Let's do B. Positive or negative? Negative, because I'm falling from left to right. How far am I going down? 1, 2, 3. Wait. 1, 2, 3, 4. Oliver's right. And then how far am I going to the right?
5.
Good. So because I went down, my slope has to be negative. So then 4/5. What about C?
0.
No, it's x equals 7.
It's 0.
I thought I was cooking there. Wait,
First,
no, isn't that a thing? If it's like straight up and down, you write that's x. It's something.
Yeah, we did that last year.
okay. Well, let's write the equation for that. It's not x equals.
Y equals.
Yeah, it's y equals 7. Because
It's like
Basically?
reverse. It's reversed.
Wait, so was that right?
close. You said x equals 7. But the question was, what's the slope? The slope. The slope is
What
0.
would it be called when you're trying to find the? Would it just be?
Equation of the line. Find the equation of the line, which would be y equals 7. Right. It doesn't matter what you plug in for x, your output is always going to be 7. So that's why your input is not there. The way that I think about it is a horizontal line cuts what axis? A horizontal line cuts what axis? X-axis or y-axis? Y. So your equation is y equals, and then whatever that y-intercept is, like that Carter pointed out, is 7 in this case. So then for our next one, our slope of D, what's our slope of that line?
0.
Undefined, because it's a number divided by 0, right? Rise over run.
It is 0.
It's not 0. You can't divide by 0.
Yeah, but
You got your calculator on you?
the cow now.
Okay.
Actually, yes, it's in my binder. I'm too lazy to get it done.
Fair enough. If you plug into your calculator any number divided by 0, your calculator will say error or undefined or something along those lines. Okay? So Oliver, if I did a number divided by 0 that is undefined.
No, it's just error.
Error. Okay? But what number did you do, Parker?
67.
Of course you did. Instead, do 0 divided by 67 and tell me what you get.
0.
Wait,
Oh my gosh.
I go up, it died.
No, it didn't. 0 divided by 67. 0.
0.6741.
No. So if you do 0 divided by 67, you get 0. So if you do 0 divided by a number, it's 0. But if you do a number divided by 0, it doesn't exist. Okay? Well, think of it this way. This is the last thing I'll say, and then but hopefully this makes sense. You can think of division as sharing into equal groups. So for example, how do you share 6 into 2 equal groups? Each one gets what? 3 each, okay? How do you share 5 into 1 equal group? 5 things into one equal group.
Oh, everybody gets
5, right?
what?
If you share 5 items into one equal group, it's 5 divided by 1 is just 5.
Oh, yeah, that's what I said.
Okay, nailed it. But if you share 0 things into 20 equal groups, how much does each group get?
Nothing. 0.
Nothing, 0. But if you share 20 things into 0 equal groups, what the hell does that even mean,
Kinda want
right?
something.
There's no thing. Exactly, that's why it's undefined. When it doesn't make sense, it's undefined.
I think everything more consistent.
All right, I'm gonna stop talking then. All right. Either way, okay. Find the value of r so the line passing through those 2 coordinate points has a slope of 8.
Wait, what was?
Undefined. All right. Okay, so we have 2 coordinate points here, r negative 5 and 313. And we know that the slope between them is 8. So I'm going to use the slope formula to do that. I'm going to write it this time. y2 minus y1 over x2 minus x1. And we're going to plug in our information. I'm going to say that's x1, y1, and I'm going to say this is x2, y2. All right, and then let's plug in all of the things that we know. So we know what m is. M is 8. And then if I do y2 minus y1, that would be 13 minus negative 5. And then x2 minus x1 would be 3 minus r. Bro is right. It's weird, right? So let's simplify that. Okay, 8, can't do anything with that yet, equals 13 minus negative 5 is, up top I get 18. And then 3 minus r, there's nothing I can do with that yet. My objective is to find r. I need to figure that out.
Ooh,
Ooh, what do we do?
multiply
By?
3 by r by 3r
By R.
by
By
8. 8.
Just saying a lot of things. None of them are right
no,
yet.
no.
Multiply both sides by?
8.
8
No.
by 3.
We want to get rid of the fraction. So what should I multiply by to cancel out the fraction?
Minus R.
3 minus r.
I understand.
I was close.
I understand it now. So my 3 minus r's would cancel out on the right side, and I would just get 18 on the right. And on the left, I have 8 times 3 minus r. I got to distribute that out. Okay? All right. So then 8 times 3 gives me 24 minus 8r equals 18. I would subtract.
Subtract 24.
Okay, so negative 8r equals.
-6.
Yes. And then.
Divide. The r equals.
Wait, how are you subtracting AR if it's?
Negative 6 over 8.
Jillian, to get from here to here, I subtracted 24. Does that make sense now? And then divide by negative 8. To get r equals,
Negative 6.
so the negatives would cancel out.
6 over 8.
6 over 8, which reduces to
2 over 4.
3 over 4.
Oh my god.
Oh my gosh. 3/4. Okay, so that's my r value. All right, questions there?
Wait, can you leave that up there?
Yeah, sure. I'm scooting, man.
Wait, can you go back over how you got
Which step to which step?
8 times 3R?
Yeah, right here.
Yeah, that one.
Okay, so here, if I clean this up a little bit,
Do you not multiply the 18 by anything? That's what it.
not yet. So we said this was 8 equals 18 over 3 minus r. My r is in the denominator, which makes it hard to solve for, right? So what I want to do is I want to multiply both sides of my equation by something that'll cancel out my fraction. So if I multiply this by 3 minus r, then these cancel out.
And you keep the top number the same.
Yes. The other way you could think about it, do you guys remember how to multiply fractions?
You multiply with the reciprocal.
Well, so that's when you add fractions, right? When you have fractions with a common denominator, you keep the numerator. But when you multiply, so when I multiply by fractions, if I like slow it down and step it out, This is equal to, because you would imagine like this is one fraction, two pieces. This is a fraction, has two pieces as well too. You would do 18 times 3 minus r over 3 minus r times 1, which is just 3 minus r. So when you multiply fractions, you multiply along the top and along the bottom. And now that I have that written in a fraction, it's easier to see that those things cancel out. And so you're just left with that 18 that's on that right side. Okay, and then on the left side, of course, I distribute it and solve, but that's how I handle the right side. Okay? It's just like if I had, I don't know, like x over 5 equals 9, and I wanted to get x by itself, what do I do to both sides? Right, and then that's easier to see, right? Those cancel out, you just get x equals 45. Okay, same kind of thing that happens over there, all right? Okay. Okay, there are 3 forms of linear equations. Oliver gave us one already. The one you guys are most familiar with is slope-intercept form. Y equals mx plus b, okay? And again, in that equation, m is equal to your slope. What does b equal, though? I think you guys told me. That's your y-intercept, which is where it intersects the graph at the y-axis. Yeah, right? Yeah, you. You saw something funny. The only thing you should be looking at is the board. I ain't writing jokes up there. Not yet. What do you call a fish with no eyes? All right.
Pretty funny.
It's a good one. All right. So, other forms that you should be familiar with an equation of a line, standard form, ax plus by equals c. So this is good for finding intercepts. Should write that. Good for, oh my gosh, finding intercepts. Okay. All right, now, this form that I will use most often, and I want you guys to use as well too, is point slope form. Okay, so that is the one that I will focus on the most. Okay, all right, now m still represents what? Yeah, but the other parts of that equation are there's a y1 and there's an x1. What does that represent?
What was it?
X1 and y1. What does that represent?
The first coordinate.
Yeah, exactly. I was waiting for him to get there as well too, but it's the coordinate, right? So x1, y1 is just a point that is on that line, okay? All right, so that represents a coordinate, okay? All right, so we're gonna practice with point slope form first. My favorite. All right, so it says identify the slope and the point given in each equation and then graph each line. All right, so it's given to us in point slope form already. What would my slope be, Jillian? Not 5.
I don't know how to do this one.
That's okay. Compare this to, and I'm going to write it above, y minus y1 equals m times x minus x1. If I want to find the slope, I'm looking for where m is at, right? So my m is just going to be this number right here, so -3. Now, 5 and 7 relate to what? That's my point. Now, what coordinate point is that going to represent? Is it 5, 7, or is it -5, -7?
-5. No, wait, it's -5,
I
7.
thought it was 7.5 because
Oh, yeah, I'm a dummy. Is it 7, 5, or is it -7, -5? It's 7, 5. Why are those numbers positive? Because when I look, they're negative here.
they're in parentheses in the equation, so when they are, like, you flip the sign.
Okay, so when they're in parentheses, you flip the sign. Another way you could think about it is your equation has negative values right there. So if I want x1 to represent a negative number, it would be a negative minus a negative, which would turn into a plus. The other way you could think about it is it's opposite. I think I heard somebody say that, but it's opposite of the sign that's there, which is probably how it's been presented to you in the past. So since it's negative inside that parentheses, I need to take the opposite of that, which is positive. But even still, y minus 5, 5 is going to be represented by y1, or y1's going to be 5. Because if y1 was negative, it would be y minus negative 5, which would be y plus 5. Okay? So my coordinate point is 7, 5. All right? Now, I want to graph the line. What do I start by doing?
Or well, you don't have it.
I don't have a y-intercept,
Your point.
so my point. I start by plotting my point. So 7, right 7, up 5, right over here is my point. Okay? And then I need to use my slope to come up with another point, because how many points do I need to graph a line? 2. I need to know what my rate of change is going to be, right? Okay, so my slope is negative 3. Direct me. What do I do from here?
Go down 3.
Down 3. I could go up 3, left 1, or I could go down 3, right 1, which I usually like to go from left to right. So I like to go to the right. But I want to show you it's the same thing. It's either way is fine. So if I go down 3, 1, 2, 3, right 1, I get this point right here, okay? Which would give me a line that looks like that, okay? If I went up 3, left 1, I would get this point, which, you know, had I been better at drawing, my line should pass through that as well too. But this is what we should get. That's our line, okay?
Why are you looking at me? That's his hand.
You gotta stop. Okay, Parker, go sit in one of those individual desks over there. We tried it. It was a good experiment. It's not gonna work. Any more than one disruption is enough for me to not be cool with it. Jillian, what's up?
Where did you get the 3 one? The one?
That's a really good question. So my slope is negative 3, but really I need to think about it as negative 3. Oh, you're okay. Okay, cool. What is my slope for example 5? A half, right? Cool. All right. What's my point? 1, negative 4. Positive 1, negative 4. Very good. So I start by plotting my point, 1, negative 4. And then I use my slope to go which directions? Up 1, right 2. So up 1, right 2. Gives me here. Equivalently, I could go both negative directions, down 1, left 2. But why would we do that?
How do you know what direction they're going?
If it's positive, your positive directions are up and right. So if your slope is positive, then you're going to go up and to the right.
If it's negative, isn't it like one?
Only one of the directions you need to change. So we would go down and to the right. Or up and to the left. Okay? You guys hammered this last year. I know you did. All right. Now I have y equals negative 6x plus 3. Let's pick out my things. What's my slope?
Negative 6 over 1.
Good. Oh, I like it. Over 1. Okay. And what other piece of information do I have there?
Your y-intercept.
Y-intercept, which is what?
3.
Good. I want to graph it. What should I start by doing?
Your y-intercept.
Okay, plot the y-intercept. And then from there, I use my slope, right? Where do I go?
Down 6.
Good. 1, 2, 3, 4, 5, 6, right 1. So it looks like this. If I tried to go up 6, it'd be off the graph. So that's why sometimes you need to choose a specific direction. Okay? How we feeling? We all right? Let's do some standard form type stuff. I need to add some notes to this if we're doing standard form, though. Standard form, like I said, is really good to find your intercepts with. Okay? How do I find my intercepts? So we got to make a note on how to do that. To find my x-intercept, somebody remember what I need to do? To find an x-intercept where it crosses my graph on the x-axis? Parker?
You put 0 in for y.
Nailed it. So to find my x-intercept, plug in 0 for y. You see what happened? I moved Parker, and then immediately he contributes to the class.
I've been raising my hand, you just have your back turned.
Oh, okay. That's possible. Hey. Oh, yeah, you're doing your thing. So to find my x-intercept, I need to plug in 0 for y. Angeline's got to take a test. Say good luck, Angeline.
Bad luck.
Oh my gosh. So I always do that anytime someone comes in to take a quiz, anywhere you want, Angeline. You guys remember that, right? I feel like that only works if it's not the same grade level. Like if a senior walked in and I was like, all right, everyone say good luck to so-and-so, you guys all say it. But then when it's somebody you know, you don't say it. Weird. All right. Let's say I want to find my or y-intercept. To find my y-intercept. What do we need to do, Parker?
Plug 0 for x.
Good. Plug in 0 for x. Okay, that means it crosses the x-axis, or it crosses the y-axis, wherever that value ends up being. So then this would be x0. Okay. So to graph in standard form, figure out your x-intercept and your y-intercept where it crosses those axes, and then plot the 2 points and graph the line. Sorry. All right. Let's do the first one. Okay, so our equation is 3x plus 2y equals 6. Which intercept do you want to find first, x or y? X. Okay. So we're going to find our x-intercept. So we're going to plug 0 in for y, like Parker said. So 3x plus 2 times 0 equals 6. Which is really easy. 2 times 0 just goes away, right? So I get 3x equals 6. So x equals what? Oh, baby. So then my x-intercept would be 2, 0. It's where it crosses the x-axis. Now I do our y-intercept. Okay? So my y-intercept, I need to plug 0 in for x. So 3 times 0 plus 2y equals 6. 3 times 0 goes away. I get 2y equals 6, which tells me that y equals what? Nice. So now I plot those points. So my y-intercept is at 0, 3. My x-intercept is at 2, 0. And then I can just connect those 2 points. What do you get when you mix red and blue? Okay. All right. Questions there? Hey, there's an even easier way that we could think about this because I know you guys are pretty good at mental math. When you are finding your intercepts and you're plugging in 0 for x and 0 for y, when it's in standard form, essentially what you can do is just put your finger over the variable that you don't want. So for example, I want to find my x-intercept. If I cover up my y value, then you just get 3x equals 6, and you divide by 3, and you get x equals 2. Boom. There it is. And then if you want to find your y value, for example, cover up your x, you get 2y equals 6, divide by 2, you get y equals 3. So that's an easy way to find it as well, too, if the numbers work out nicely, right? But if I play that same game up here, for example, 8, let's say I want to find my x-intercept. So I'm going to plug in, I'm going to cover up my value for y. And I get 4x equals 12. Divide by 4, you get what? So my x-intercept is going to be 3, 0. Okay. All right, let's play the same game for the other one. If I cover up my x value to find my y-intercept, I get negative 3y. I got to keep that negative there. Negative 3y equals 12. What's my y-intercept going to be? Good. So 0, negative 4. All right, I did that one a little faster. Are we okay? Yeah? Okay. So I plot So 3, 0 is a point, 0, -4 is a point, and then I just connect. Okay. How we feeling? Yay. All right, equations from graphs. I'm hungry. I want a sandwich. I feel like that's what I'm in the mood for. I brought chili though. I hope you guys are hungry for equations of lines. What 2 ingredients would you need to make your equation sandwich with your line? It's like the worst transition I've ever done. We'll workshop that one. We'll try that again. What 2 things do we need to write the equation of a line? Slope and? Yeah, if I'm doing like slope-intercept form, I need a y-intercept. Otherwise, what could I use that's a little more accessible? Point. So we need a point, and we need a slope. For the record, the y-intercept is a point as well too, right? All right, so if I need a point and a slope to find the equation of a line, what's the best form to start with? Point-slope form, right? Because it has all those things just very clearly defined where you need to plug them in. So point, slope, form. Exclamation point, smiley face. Now, remember, that's y minus y1 equals m times x minus x1. I really am hungry, though. I didn't eat my midday granola bar.
What about your apple?
It's still in the fridge. I didn't even bring it to the classroom. I was so busy today. I know, dude. It's in the fridge here, so I'm going to eat it here in a minute. But all right, so write the equation of the line, graphed. So I need a point and I need a slope. Well, let's identify what my points are. They gave me 2 of them. What's this one up here?
Oh, that one?
That little guy.
4, no, 3, 5.
Okay. And then my other point? Okay. So there's my points. I don't need both of them. I just need one. I don't really care which one we use. But we do need to find the slope. And when I find the slope, I need to use both of them. Don't do that. Please. Okay, so I need to find my slope. Okay, so y2 minus y1 over x2 minus x1. Or I can just count, right? How far am I going up? Up 3. So 1, 2, 3. And then right, how many? 1, 2, 3, 4. So my slope is 3/4. Okay, cool. So if I have a graph, that makes it pretty easy. All right. Now I want to write the equation of my line. So which point do you guys want to use? 3, 5 or -1, 2? Doesn't matter.
3, 5.
3, 5 it is. God, I wish that point was to the right 3 more and up 2 more. You guys Carter would have lost his mind. All right, so y minus y1, which is 5, equals m, which is 3/4, times x minus x1, which is 3. It's supposed to be a 3. But, you know. I can't use the excuse that I'm new anymore. I've been writing on an iPad every day for the past 2 months, so. All right, 3/4. Okay, so now we should get it into y equals mx plus b form. So solve for y. So y minus 5 equals, now I need to distribute 3/4 to both of those. 3/4 x minus, what is 3/4 times 3? Nope, not 6/4. You are doing 3/4 times 3. Do you remember how we do that? If not, that's okay. That's why I'm stepping this out.
9/4.
You end up with 9/4. You should think of 3 like 3/1. And then when you...
But I added the numbers on it.
You're not stupid. When you multiply fractions, you multiply across the top and across the bottom. So you would get 9/4 in this case. All right, so minus 9/4. Now, We're going to have an opportunity to add or subtract fractions here in a second. So buckle up for that. I still need to solve for y, so I'm going to add 5 to both sides. Y equals 3/4 x. Ooh. I need to do negative 9/4 plus 5. So I'm going to do that off to the side. Negative 9/4 plus 5. So now I'm adding a number instead of multiplying. How do I add fractions together?
Something over 20.
Yeah, well, so I got to make it over, well, I got to make my second number a fraction, right? So I need to put this over 1 and find a common denominator. What would my common denominator be? Not 20.
Wait, 4.
In this case, it's just 4, right? So I need to multiply top and bottom by 4 to get negative 9/4 plus 20/4. What is negative 9 plus 20? 11. So when you add fractions together, you must have a common denominator, and you add the numerators and you keep the denominators the same. So negative 9 plus 20 is 11. So 11/4 would be our value. I think of it this way. The denominator is kind of like a label or a unit of measure. What is 5 pumpkin pies plus 3 pumpkin pies?
8.
8 pumpkin pies. What is 5/4 plus 3/4? 8/4, right? So the fourth is kind of like a unit of measure or a label. Okay? That is when you add fractions. All right, cool. All right, last one, and then I'll be done talking at you. Write the equation of the line graphed. What type of line do we have? Vertical line. Which implies our equation is going to look like what? Is it x equals or y equals? X equals. What number? Negative 3, because that's where it crosses the x-axis, is at negative 3. Okay? All right. Questions there? Hey, we did it. And we didn't do a single proof. How do we feel about that? Alina's dancing. She's so happy we didn't do any proofs.
77.
This is supposed to be an arrow, like implies.
They're really simple.
Sorry. All right, worksheet. There's a lot of problems on here. There's like 12 or 13, but a lot of them go fast. Finding slope. Home today? Home game today? How much?
It's at Talmadge.
You gonna get on the field?
You just
What would they put you in for? Special teams?
More up because I have 2 seniors.
Oh, okay. Anybody not get a worksheet?